So anyway, welcome to 622, second day of class. First day, quite hectic. Most of you guys, some of you guys got started on things, which is cool. If you didn't, that's fine too. So just a couple quick announcements again, since we started the recording. The quizzes got mixed up. I posted the quiz 3 or chapter 3 quiz first instead of the chapter 2 quiz. Both quizzes are up now. You can take them both. So don't worry about that too much. If you've already taken it, great. You're good to go. The new quiz I just posted this morning. Now, as you guys know, the quiz is how we take attendance. So I put the quiz up. That means it has to be due today. So today's quiz and last time's quiz are both due today by 11 o'clock. I'm usually up at 11, so I'll do that. And I don't need to take attendance like by a certain time. I just need to have collected your work. That's what's nice about asynchronous classes. So those quizzes are up. Remember, the classwork is there just to help you. You don't have to turn that in. The other announcement was that the first exam is going to be available tomorrow morning. And it'll pop up. It'll be under quizzes. I'll make an announcement saying the exam's available. Check it out here under quiz. It's called the chapters 2 and 3 exam in the quiz section. You get 3 hours to do it. You can take it one time. So there's that. Those are the announcements. And again, hopefully we can get this switched over to Citrus soon. Remember, you can find everything that we're doing for each individual unit in the modules down here, and every single resource also available for that particular unit. So if you were doing the quiz and since I messed up and posted the wrong one, you could have gone in there and like, oh, he was actually talking about metric conversions and significant figures, so I should go into that instead of the other one. I got them mixed up. No big deal. So those are the announcements. Let's get started. Do you have questions on classifications of matter, which is mostly the chapter 3 stuff, or 2 stuff, and then the metric conversions? If you haven't looked at any of that stuff today, that's fine. You could just simply ask me to explain a topic, and I will. You do have control of your mute. So if you want to talk, just say, I have a question in the chat, and I'll say, go ahead, and you can unmute yourself and ask your question. Let's try this. Can you hear me? Okay. Well, there you go. There you guys are. So, thank you for everyone responding. Sophia says she has a question about the worksheets. You can either type it in chat or you can unmute yourself, Sophia.
Yeah, I had a question about the assignments, because on Canvas it says it's due to, like, for chapter 2's worksheets, it says it's due today, but it like won't let you submit anything.
Yeah, you don't need to submit anything for those. So in Canvas, for the worksheets, if you go to the modules here, the classwork here, you'll notice they're worth 0 points. And that's because I didn't want you guys to have to print all that stuff out and then show me like pictures of the completed work or scanning it in. So I didn't want you guys to waste paper. So you don't have to actually print those out. Those are there to show you, like, if we were in class, this could be a good way for you to take notes. They're like a note-taking aid as you work through the book. So when you look at those worksheets, I'll just go here. And say you started right here at the beginning. You know, this PDF file is a few pages, and I just didn't want you guys to waste paper. So if you wanted to just work on this on a separate sheet of paper while you were reading the book or while you're watching the videos, or you could even use it as a way to skim through the stuff where you have, you're like, okay, I got to learn about mass today. And so it says properties used to describe matter can be classified as, and then you go watch the video and, oh, okay, take notes as time goes on. So these worksheets are basically acting as your notes. So if you'll notice in the section, when you look at the grades, it talks about classwork versus quizzes versus exams, and it gives classwork 20% and quizzes 20%. And that's because right now we were just doing this for classwork, but we will be doing a couple other assignments as well, things like at-home labs and whatnot. So while these are worth nothing, the worksheets, other stuff will be worth something. But for those, didn't have to turn them in, don't have to print them out. Don't worry about it. So yeah, those worksheets are there to help you. So Catherine has to, we only have 2 worksheets to do today, and the chapter 2 quiz due tonight. So the 2 quizzes are due tonight, so I can take roll. One quiz was from Friday, and another quiz is from today. But I left the Friday quiz open, so you can still work on it today. Those quizzes you can retake. So if you're taking them and you get something wrong, you can retake it. Don't worry. Just make sure you're using your first and last name. We'll talk more about the quizzes in a second. And then I have a question on packet 2.3, question 4. All right, perfect. So 2.3, question 4, it says, it's a big long sentence. Are you talking about number 4 here, Mr. Food?
Yeah, I'm talking about number 4.
So it says a substance is either blank or a blank. So a substance is either a element or a compound. And it says compounds are made up of elements which are always present in the same ratio in a given compound. So that's what they mean by that. So what are they saying? So a compound is, oops, I did the wrong thing. But either way, get rid of this, go away. We want a whiteboard. So when it comes to elements, you have the periodic table. I'll post a periodic table for you to use. Oops, distance learning. There we go. So we have, say for instance, we have hydrogen and we have helium. These guys are elements, and as long as they're just individually like this, we call those pure substances or elements. But hydrogen likes to hang out with oxygen, and when these guys come together, they make the compound water. But water has to be in this ratio with H2O. And so that's why number 4 is ratio. A good example of this is water can also combine to produce hydrogen peroxide, which is very different than water. The funny joke, chemistry joke, not really that funny. A guy walks into a bar, says, I'll take some H2O. The guy next to him says, you know what? I'll take some H2O too. Well, he dies because hydrogen peroxide will kill you. There you go. Funny joke. Anyway, so, and then we have, can we review number 8 on chapter 2, 2? Yes, we can. So number 8 says homogeneous mixtures can be separated by distillation. So if we look at the different mixtures, measurement, did I put it in the beginning? Either way, if you look at the different types of mixtures, homogeneous versus heterogeneous, say we had a beaker and we had, sorry, 2 beakers, and we had some water in the beaker. Well, if you were to drop some salt, for instance, into the beaker, which is sodium chloride, it would completely evenly distribute throughout. So if you took a sample of the top of the water, you'd have NaCl and you'd have water. And then if you took a sample from down here, it would be the exactly same thing. This is what we call a homogeneous mixture. And homo means same. So this means same throughout. That's what homogeneous means. So it says a homogeneous mixture can be separated by distillation. Well, let's look at a heterogeneous mixture. Well, say we threw some sand in here. Well, the sand would just kind of go down to the bottom. And so if you took a sample up here, you'd just have water. And if you took a sample down here, you'd just have sand. But if you shook it up, you might have this kind of like floaty bit where you have some sand and water. The reason why this is called a heterogeneous mixture is it's different throughout. Top is different than the middle, which is different than the bottom. So when it comes to separation techniques, some separation techniques are good for, what are we laughing at? Some separation techniques are good for homogeneous and some are good for heterogeneous. So the ones that are good for heterogeneous are filtering. So just like making coffee in the morning, you filter stuff out. And then you could also do chromatography, which is a fancy way of saying another type of filtration. It just uses different size materials. And then those are the 2 really good ones. Over here, if we want to get the salt out of water, what we're going to do is what's called distillation. Okay. So what is distillation? We could also use crystallization over here, which is just letting the crystals form as the water evaporates. So what is distillation? Distillation, basically, if we have a solution, we heat it up. And the water will boil at 100 degrees C for water, but the salt won't. And so the salt needs something like 1800 degrees C to boil. So if we just heat this up to like 101, all the water will boil away. Now, normally distillation is used for 2 liquids. So in the case of like ethanol, which is CH3CH2OH, and water. That would be something like alcohol that you would buy at the store. They might say triple distilled or something like that. And that is when they separate these out based off of their boiling points. This guy boils at 87 degrees C. This guy boils at 100 degrees C. So if we just bring this up to 87, the water will stay in one beaker while this will evaporate out. And we can collect it, either using a tube or another beaker or any of those other techniques. And that's called distillation. So yeah, you guys have any other questions? Or were you just listening right now? Question 21 on 2.4. All right, and then we'll do 2.4 again and then 3.3. Perfect. All right, so let's go back to 2.4. So let me do that one. All right, so 21. All right, so for this one, let's go ahead and do a snapshot. So in number 21 on 2.4, we're looking at the concept of the law of conservation of mass. And what the law of conservation of mass states is that in a chemical reaction, the reactant's mass will equal the product's mass. Because the law of conservation of mass says that matter cannot be created or destroyed. So if we look at this, we have methane, and it's combining with oxygen. So these two guys are our reactants. And then it says we have 44 grams of carbon dioxide and water. And it says, what is the mass of the water produced? Well, remember that the masses have to be equal. So 16 plus 64 has to equal 44 plus some number. And most of you guys are pretty advanced math kids, so I'm sure you can figure that guy out. But this is 80, so then this is 44 plus x. So what's that, 36? So that's the idea. It was just kind of a numerical expression of the law of conservation of mass. And so speaking of which, we had questions for 19 and 20. So let's go over those. All right, let's get rid of this guy. So 19 and 20, same idea. So let's just blow it up, work on them together. So we have 400 grams of wood, and they're burned. So wood is our reactant, and we're going to react it with some oxygen. And it says 30 grams of ash remain. It says what happens to the 370 grams of matter? So where'd it go? What do you guys think? You can either type in the chat or you can unmute yourself if you want to answer.
I think it could have turned into gas or smoke.
Exactly. So if you think of a fire, you have your log on here and it's burning. Well, look at the reaction. We have wood and oxygen, and guess what? It becomes CO2 and water. And so these guys are gases. So all of that mass is being turned into a gas and it's floating away. This is one of the early signs of something else happening on the molecular level, is they started being able to understand how burning reactions worked. And so some of the early experiments were to burn a very small thing like a match inside a jar full of oxygen. And what they would notice is when they would keep the lid on the jar, the mass of the reaction would not change. So they were capturing those gases, and they were noticing that if you kept the lid on the jar, the mass would stay the same. Famous people who did experiments like that are Lavoisier and Avogadro, Dalton, all kinds of guys. Some car batteries give off potential explosive mixture of gases. What kind of change is taking place in the battery? So batteries are chemical potential energy. So they're going to undergo chemical change. In a battery, it's called a lead acid battery. And there is lead and there's lead sulfate. And the electrons that are on the lead get removed when the lead becomes lead sulfate. So these two electrons bouncing back and forth between these two states is how we charge our batteries in our car. So they're changing their properties. Lead is a metal, lead sulfate is a ugly gray goo, changing the physical properties. All right, can we go over question 1, section 3.3? Sure, check it out. We want, so let's go back to modules. So 3.3. All right, so it says whenever two measurements are equal or equivalent, a ratio of these two measurements will equal 1. One to one. So if you have 8 boys and 8 girls in a class, that's a ratio of 8 to 8, which equals 1.
Sorry, I meant the last worksheet with the review for all the.
Oh, with everything? Okay.
Yeah.
Okay, so 3.3, question 1. All right. So if we look at this question, it says the population of San Francisco is 750,000, 49 square miles. It says, what is the population density? So let's go look at density. Density is normally mass over volume for science classes. And that's the questions that are also on that page. But in this question, they're asking about population density, which is going to be people over volume. Which, if we look at the question, says 750,000 people in 49 square miles. And it says, what's the population density in San Francisco? Well, if we didn't touch anything, then we would just do 750,000 people per every, what is it, 45? 49. 49 square miles. Miles square. And then we could just get out our calculator. $750,000 divided by 49. So we would have 15,306. Now we want to write our answer in correct sig figs. So if you have questions on those, we'll get to those in a second. But both of these numbers only have two significant figures. So we're just going to round our digit to 15,000 people per mile squared. So it's roughly 15,000 people per square mile. But the question says, express your answer in people per acre. And it shows us that an acre is 1 mile squared. So instead of, all we need to do for this problem, since we solved it for miles squared, is write that as acres with the conversion factor that 1 square mile equals 640 acres. So when we go here, we can write this as 15,000 people, and it was per 1 square mile, but a square mile is 640 acres. So then we can just do the simple calculation again. So take our answer and divide it by 630, 40. And then we get 23.9. And again, if we're trying to do significant figures, then we want to just do 24 people per acre. So, does that help? I don't ask you that elaborative questions on the test. Those are just, a lot of these worksheets have like challenging questions. So if you can do these worksheets, you'll be blowing the test out of the water. So another way to do this with conversions is a technique called dimensional analysis. So let me show you that. All right. So we found, go away, what are you doing? We found that it was 15,000 people for every 1 mile squared. Well, our conversion factor was for every 1 mile squared, we had 640 acres. Notice how that's the exact same math problem. But the reason why this is called dimensional analysis is what it shows us is if we treat these things like fractions, if we multiply the fraction on the top versus the fraction on the bottom, the miles will cancel because they're on both the top and the bottom, and we'll be left with peoples per acre. And so that's called a conversion factor. Next question. On the test, I just asked you to do basic metric conversions. So questions like, if you have 15,000 meters, how many kilometers is that? And so you'll just do the basic dimensional analysis where you say for every 1,000 meters, there's 1 kilometer. And so most of you guys are probably pretty versed with the metric system and know to just move the decimal 3 places. But if you don't, you can also use the metric conversion factors that we have here. In this case, we just have 15. What else you got? I think we answered everything so far. All right, so significant figures. So what is the point of significant figures? So imagine, if you will, you need to measure out 100 milliliters. But you need to be accurate to the 10th place, okay? Well, your equipment in the room say you had a beaker, it's just going to have a few graduations on it. It might say 0, it might say 50, it might say 75, it might say 100. You can't be accurate to any numbers in between those. You just can't see them. So then you get out another piece of equipment with like a graduated cylinder. Well, if you have a really big graduated cylinder, it might go 500, but the very next line might be 490. So again, you can't be accurate to these digits. So the point of significant figures is to tell someone who's reading your work how accurate of a piece of equipment you were using. So if I write, for instance, that I weigh 100 pounds, I don't, but if say I wrote, well, say 200 pounds, that's telling you that I am pretty much just guessing, because this number here is significant too, but I don't really know these digits. Now, if I said I weigh 200 pounds exactly, then we would have 3 significant digits. Because what I'm telling you is that I got on a scale, and the scale was accurate to the 1 pound mark. But say I told you on my piece of paper that I weighed this many pounds. Well, what that's telling you is that my scale was accurate to the 10th place. So the point of significant figures is to tell other people who are reading your work how accurate your piece of equipment is. Now, the reason why this is so important is things like density. Density is mass over volume. So if you use a very highly accurate mass measurement, but use a very, very low accuracy volume measurement, well, how accurate is your density? It can only be as accurate as the lowest accuracy measurement. In this case, that would be our volume measurement. So the rules for sig figs are pretty simple. Any number 1 through 9 is considered significant. So the 1 and the 2s, they're all significant. So the only annoying thing are the zeros. So when zeros are placeholders, like these guys here, they're what we call insignificant. You can't be sure if the person actually made that measurement or not. The number, those zeros have to be there to make 200. But when I add my decimal point here, they become significant because they're no longer holding the place. The decimal point is doing that. And so I have measured 2 hundreds, I've measured 0 tens, and I've measured 0 ones. And that's the same thing for this. This now has 4 significant digits because I have measured this digit. So I wrote it there. This is considered not a placeholder 0 because I don't need it. If I got rid of it, it would still be 200. So I'm writing it there to tell you the accuracy of it. So looking at some numbers like 74,000, that only has 2 significant digits. But 74,010, this one has 4 significant digits because this guy right here is what we call a sandwich 0. It is a placeholder, yes, but if I measured this digit, then I most likely also measured this one. But this one I can't be sure of, so we don't count it.
Are you saying that the last 0 or last set of zeros is the number that is insignificant?
So the significance of a number tells you if you actually saw it. And so if you see a 1 through 9, you're telling your reader that you saw that on your piece of equipment. So the only ambiguous number is 0. So if a 0 is just hanging out by itself after a number, those are called placeholder zeros, and we can't be sure. So we just assume they're not accurate numbers. But if I add a decimal point here, I'm trying to show you my accuracy, and those zeros become significant. For the sake of this zero down here, I don't need this zero. It is not a placeholder zero. I'm only writing it there to show you how accurate I was. So we assume that it's an actual measurement, and so we call it significant. Now, in the case of this over here, the reason why this zero is significant and this zero is not significant is because of this number right here. The rule is 1 through 9 means that we measured it. So if we measured this and this and this, how could we not measure that? Doesn't make sense, right? The only way that could happen is if you went to that scale that your doctor has where they move the weights around and maybe they're just missing the 100 weight or something, but that doesn't make any sense. So 0 is the only ambiguous number. And so really you're just asking yourself this question. Does the 0 need to be there? Yes, then you probably don't know if it's accurate or not unless someone has gone out of their way to make it accurate for you, like adding a decimal point. Does the 0 not need to be there? Then they are trying to show you that that is a significant digit. So here's a good example. 1.00 is 3 significant digits because this is the same value as 1.00. It's just 1. But I wrote those because they're significant. But 0.001 is only 1 significant digit because these guys have to be here to hold the place. Even though that decimal's there, those zeros are there to tell me the value of this. And again, the video that I've provided, it's only like 10 minutes. It's a little bit quicker, easier demonstration. All right, so for the sake of time, let's move on to, they want 2.3 number 10 and 2.4 number 5. Do you guys want them off of the whole sheet or just the, like, do you want this number 10 right here?
Oh, yeah. Part B, for part B, please, on 2.3.
So this key word here is physical. So compounds can be broken down into elements by physical means. And so what does physical mean? Think of water. If you hit water with a hammer, will it split into something else or will it just splash water everywhere? Yeah, it's just going to splash water everywhere. But if you were to chemically mess with the water by either putting electricity through it or doing a chemical reaction with it, you can separate the water into the hydrogen and the oxygen. So the fact that they use the word physical means that it would be something like separating a mixture. And compounds cannot be separated physically. It's one of their defining traits. Did that answer your question? Okay, someone asked for number 5. Do you mean this number 5 or are you talking about the...
Yeah, I mean that number 5.
Okay, so the only way to be sure a blank change has occurred is to test the blank composition of a sample before and after the change. So in these things, we're talking about chemical versus physical changes. So we just kind of got into it a little bit. A physical change is any time you just physically change the substance. So this is stuff like melting or boiling or smashing. If you have a rock and you smash it, it's still rocks. They're just smaller. If you take ice and you melt it, it's still H2O. You didn't change the chemical composition. So in the case of a chemical change, we are changing the chemicals and how they are coming together. So we have to look at the stuff before and after, and we have to look at the physical properties. The best example of this is a match. If you look at a match, it is a piece of wood with chemicals on the top of it that when you get them hot by rubbing them across the scratch pad, they catch fire. So once the match is lit, can you relight the match? And the answer is no, because the chemical and physical properties of the match after the reaction are different than before. So what this is saying here for number 5 is it's saying the only way to be sure a chemical change has occurred is to test the composition of the sample before and after. Now we have evidence that a chemical reaction has occurred, and these things are changing, giving off the heat or getting cold, so changing of the temperature spontaneously, meaning it does it when you just mix them together, or what we call forming a gas or forming a precipitate. So if you mix things together and they bubble, or if you mix things together and they weren't a solid before, but they are a solid now, those things are good examples of evidence for a chemical reaction. But what we do want to do is we want to look at both those properties at the beginning and at the end. Sometimes it's difficult. A good example of this is the acid hydrochloric acid, which is in your stomach, and the base sodium hydroxide, which is a commonly used base. They both are clear liquids, and they both conduct electricity, but when you mix them together, it makes a clear liquid that conducts electricity. And so the only evidence that you have there that a chemical reaction took place is that if you feel the beaker, you'll notice that it got hot. But the chemical and physical properties look to be about the same. So sometimes it's hard, but that's what they're asking there for number 5. What else we got? Okay. Now remember, just because we went live and we talked for 45 minutes, and you guys had a lot of good questions, if you go out to work today and you have another question, go ahead and either put it in the classroom. I'll have the you can send me individual conversations, and I can answer your question there, or you can shoot me an email and it'll pop up and I could answer your question there. And we can either go live on Zoom again and you can see what I'm doing on my screen, or we could use Hangouts, whatever you want. And I'll answer your question. So even if you don't have a question now, don't think that, you can't ask any questions between now and the exam. So it depends on you. PowerPoints are just kind of a summarized of the text, and the worksheets are there to help you go through things systematically. I use the textbooks worksheets so that you could follow along with your textbook, but you could also just use the videos that I provided. You could also type in any topic we're talking about into YouTube or any of those other video sharing sites, and you will find hundreds of videos that talk about that particular thing. For instance, you had a question about significant figures. Well, if you go down to the module here, you'll notice it says significant figures right there. And while it's not a PowerPoint, it is a YouTube video where the guy from Khan Academy explains significant figures to you. Lots of good examples. It's only a 5-minute video, so easy to watch. So what I recommend is to work through the worksheets. You can either use the book or you can use the PowerPoints or you can use the videos. And then if you have a question, then you can ask me and I'll answer it either during the live session right now or anytime when you're working. Obviously, if I've gone to sleep, then I can't help you, but I'm usually up, when you guys are up. So someone said, when do we start the next unit? Jojo. This unit is ending today. So we talked about both chapter 2 and 3. The quiz is today. Tomorrow's live session, I will answer questions on 2 and 3 again. And then I will give you time during the day to take the test. So the new stuff, the chapter 4, 5, and 6 stuff, will happen on the 24th. There won't be a quiz tomorrow because your exam will be your credit, your attendance. So you don't have to worry about a quiz tomorrow. We're basically going to be doing a chapter a day. So if you want to think of the schedule, we have tomorrow is your exam, our live session. I'll answer questions. So even though the exam will go live tomorrow at 8, if you don't want to start it until after the live session, that's fine. You have 3 hours to do it. It is due by 11, so obviously you need to start it at what? 8 o'clock. So start it at least by 8 o'clock. When we come to class on the 24th, we'll be doing chapter 4, 25th, chapter 5, 26th, chapter 6. On the 29th, we'll do exactly what we did tomorrow, which is I'll answer questions. You'll have the exam available to you if you want it, take it. And then we have 7, 8, and 9, and then exam, and then we have 10, 11, 12, exam, and then final exam. So basically assume a chapter a day. Now, sometimes I'll tell you, don't worry about a particular section in that chapter. For 2 and 3, we did everything, but for some of the chapters, we won't do a particular section because it's just not pertinent or they just don't cover it very well. So don't worry, I will tell you that when we get there. If this was the citrus course, everything would be up. You would see everything, but I'm being cautious on dumping everything on here because it already is fighting me and transferring things. So once the citrus course is good to go, you'll be able to see everything we're doing every day. Anything else? Okay. Well, remember, if you have more questions, feel free to ask them. I will answer them for you throughout the day. If you would like to see me work a problem out with you, we can go live either through Hangouts or Zoom or what have you. And I'll use that same link for that day. So I'll open the meeting and then you can just pop right in. So the meeting will be at 11 again tomorrow. I just made the test available at 8 in case some of you guys are early birds and you want to get started on it. So I'm basically going to make the meeting every day at 11. Most of you guys were 10 to all the way to 6 or 9 o'clock at night was where you wanted to meet. So 11's a good compromise. But yeah, I made the test available at 8 because, some of you were up early and maybe you don't need me to help you. And so you just want to get started. That's okay. Just remember you can only take it one time. So you want to make sure that you're, prepared, and you have 3 hours. So take your time and go through things. So the test will be like an assignment. It'll pop up. You can see it right there under quiz. It says quizzes because they don't have an exam section on here, but I have it as if you look at the assignments, there are 3 categories of assignment. There's classwork, there's quizzes, and there's exams. So your quizzes right now are worth 10 points each, and I will go and get them from quizzes. I'll show you that in a second. And then right down here it says exams, and those are 60% of your grade, and those show up over here under quiz. This lets me put it into Canvas. So you go to take it, it'll pop up, it'll give you a time. Because you are logged in here, it logs it for you. If you get dropped, if something happens, let me know, and I can give you access to the quiz again, or the test again, after something goes wrong. It's supposed to automatically do that for you. So it's right there. It's inside Canvas. It's a multiple choice test because that's what Canvas supports. For chemistry, it doesn't do math very well. So I just made it multiple choice for you. And again, if you can do the worksheet questions, this will be easy. Very similar wording, but I took out ambiguity in places where they like to put ambiguity in things. So that's the exam, and that'll be live at 8 a.m. all the way to midnight, basically. So yeah, again, it's asynchronous, so I wanted you guys to be able to do it whenever. But again, you can only take it one time. And that'll pop up. It'll automatically grade it for you since I've already put the answers in there. And of course, it'll be associated with module 1 point, or unit 1, chapter 2 and 3. So that'll pop up there. Our video from today will also come up today. It takes about 30 minutes for it to process it. Then I transfer it, and then I put it on YouTube, and so it's on there. Unfortunately, Zoom to YouTube makes the quality go down a little bit. Sorry about that, but it's just how it is. I try and write really big to get over it. I can use OBS and things like that, but tends to bog this computer down pretty bad. So don't be too worried about the test. If you're doing the worksheets, if you're answering the quizzes without much resistance, then the test will be very similar. Only difference between the tests and the quiz is that you can't retake the test. That's it. So let me show you what I mean by what quizzes shows me. So how do you get your points for quizzes? So I asked you guys to use your first and last names, because if you already have a login with Google. Okay, so if you're using your first and last name, when I go over here to reports, unfortunately, I called the first quiz Chapter 2 quiz, even though it's on Chapter 3, but the title of it doesn't really matter. Both of these quizzes are running. You can see that 36 of you have jumped onto the quiz and have taken it. So if I click on this, it shows me the report, and it will show me your names and your grade. So then I can go in and I can put that into right here. I can give you guys all grades for that. So you want to make sure you're using your first and last name, so that way I can give you points for it. Now the quizzes do close after a certain date, but of course, if you want to use them for practice for the exam, today it's no big deal because they're going to be open for the same amount of time that for when the exam opens. But for later units, when we have, a couple chapters, a quiz might expire. So if you'd like to retake the quiz for practice purposes for the exam, just let me know and I'll reopen the quiz. I just want it to close at a certain time so I can use it for attendance. So like if you've taken this quiz, you did attendance. It doesn't matter what score you got on it. I just am using it to take attendance. And then it's worth 10 points. So if it says you got 100 points, you got 100%, you got 10 points. If it says you got 90%, you got 9 points. And I round up. So if you got 95, you get 10. If you got, 85, you get 9. So it's a lenient system. Questions on that? Okay. Well then, it's been a good long hour. I don't want to waste up all of your day. I'm going to go ahead and stop recording here.